In the last video, we talked about the 5 different theorems that allow us to prove that 2 triangles are congruent. If you need, go back to that first video and refresh on those. I'm going to go through a few examples of a full proof of how to prove 2 triangles are congruent to each other. So in this proof, we're given 2 triangles. Here they are. We're given that TV is congruent to VW. I'll go ahead and mark that on your picture just so you can keep track of this stuff. So TV is congruent to VW. So we got those 2. And we've got UV is congruent to VX. Prove the triangles are congruent. So you would probably want to write all this down as the given as your first line, but since they already have it written for me, I'm not going to write down any of the given stuff. As it is though, this is not enough to prove that 2 triangles are congruent. I've got a pair of sides and another pair of sides, but side isn't enough. I need side, angle, side doesn't work, so basically I need something else. Or I could do the third sides, although I'm not going to be able to solve for that third side because this is not a right triangle. So what I have actually is that these 2 angles are congruent. I know that because they're vertical angles. They're across from each other. So I could say angle UVT is congruent to angle XVW. And I know that because they're vertical angles. And vertical angles are congruent. And then that's pretty much it, because that is side, and an angle in the middle, which is side, angle, side. So I can conclude that triangle UVT is congruent to triangle XVW because of side, angle, side. Okay, let's try another one. I'm gonna bring this down. Remember, you don't have to do a proof as 2 columns, but it can help you organize your thinking to be like, I need a statement and the reason for it. It could be a paragraph if you really wanted it to be, but it just kind of helps us organize. So again, I've got 2 triangles here. It says C is the midpoint of AD. So C is in the middle of A and D. And C is also the midpoint of B and E. Prove that they are congruent, the 2 triangles. So the first thing I'm going to say here is that BC is congruent to EC. Basically, these 2 are congruent. How do I know that? Well, it told me C was the midpoint, so those are the same. That's literally just the definition of midpoint. So I'm just going to put, that's the definition of what a midpoint is. Or you could say something like, a midpoint divides a segment into 2 congruent segments, anything like that. I also know that AC and DC are the same for the same reason. I'm just going to comma and put those on the same line. Okay, I also know that these vertical angles are congruent. So I can't just say angle C is congruent to angle C, because which angle C? So I'm going to say ACB. Angle ACB is congruent to DCE. Making sure everything matches up. And that's because they're vertical angles. And that's all I need. Because at this point, I have side, angle, side, side, angle, side. And so I know that triangle ABC is congruent to triangle DEC because of side, angle, side. All right, let's do another one. This is the last one we'll do. Also, one thing I wanted to say about this, sometimes people ask, does the order in which you write these things matter? Yes and no. You should always start with what you're given, and you should end with what you're trying to prove. So start with the given, end with the conclusion that yes, they are similar. But the stuff in the middle usually doesn't matter as much. Like, I could have put the angle thing above the whole congruent segment thing, and that wouldn't have mattered because it would still be side, angle, side. Okay, so one last final problem here. It's given MJ is perpendicular to NK. Just by the way, this little like T looking thing means perpendicular. It's exactly what it looks like. It means you've got right angles, basically. So those are 90 and 90. I know you can't read that. Anyway, that means MJ and NK form right angles. That's why I have a little right angle there, and I could put a right angle here too if I wanted. I'm going to go ahead and write that in my proof. So that would be the first line because given. And then in the next line I could say, all right, well, angle MJN, MJN is equal to, well, is congruent to angle MJK, and they're both equal to 90 degrees. And that's because they're literally right angles. That was because MJ is perpendicular to NK. Or you could say, like, that's the definition of being perpendicular. Okay. Next, it told me MN is congruent to MK. I've already got that marked on here. So let's see what we've got. I've got these sides and these angles. Angle side or side angle is not enough to prove that these are the same. You may notice though that this right here, this segment is a side on this triangle and it's a side on this triangle. They literally share that segment. And so MJ is congruent to MJ, it's congruent to itself, and that is actually called the reflexive property. We'll talk about that in a second. Anytime something is just equal to itself, it's called the reflexive property. Okay, so now let's think about what we've got. We've got two sides and an angle on the outside, two sides and an angle on the outside. So I've got a side, and an angle. Is that one of the congruence theorems? It is not. If I were to write this backwards, this would be a bad word. That one doesn't count. So how do I know these are congruent? Well, they were right triangles, and I have the hypotenuse is congruent and a leg is congruent. And so this is actually hypotenuse leg. I know that these are right triangles and that's because they have a 90-degree angle in them. The reason for that is the definition of right triangles. I'm kind of going overkill here, but you get the idea. And so I know triangle MJN is congruent to triangle MJK because of hypotenuse leg. They're right triangles, they share a hypotenuse, that was given, and they have a congruent leg because it was literally the same leg, and so that's hypotenuse, leg, there we go. All right, I want to share with you just a couple properties you might use. One of them we just mentioned. It's called the reflexive property. Anytime you say something is just equal to itself, it's called the reflexive property, like you reflect on yourself, or it's reflected back to you. The symmetric property basically just says you can flip things if you ever need that. Like if you want to change AB is congruent to CD and flip it CD is congruent to AB, that's symmetric because it's symmetry. And then the transitive property basically just says you can like link things up like a train. Like if AB equals CD and CD equals EF, then I know that AB also equals EF. Like they're just all the same. Or if AB is congruent to CD, CD is congruent to EF, then AB is also congruent to EF, and you can skip the middleman. So these are three properties that you might use in proofs every now and then. Mostly the reflexive property is one that you'll see in these proofs.